Rain clouds are gathering on a chilly afternoon in Ann Arbor, Michigan. Time to release some water from the Ellsworth Detention Pond on the edge of town. All it takes is a few taps on a smartphone, and these two 12-inch valves open up. Like many cities its size, Ann Arbor has had to grapple with aging stormwater infrastructure. More people and more buildings mean more strain on the system. This pond dates back to the 1970s.
We're in an urban environment. We're kind of boxed in. We don't have room to make the pond bigger. What we need is something innovative and different to make the pond function differently.
With support from the National Science Foundation, civil and environmental engineer Branko Kirkez and a team at the University of Michigan are building a new generation of smart and connected stormwater systems.
That's kind of the vision behind this, is instead of new construction, what you're able to do is take your existing system, retrofit it with these autonomous technologies, and effectively squeeze more out of it.
They start by deploying wireless sensors all through a watershed, especially areas prone to flooding during storms. The sensors are programmed to monitor and wirelessly report back data, like water levels and flow rates.
We actually want to go into a city or into a community and figure out how their stormwater systems are actually functioning. And you won't really know what they're doing until you measure it.
So the green nodes indicate that the sensors are operating well and they're sending us real-time data.
They're developing algorithms that sort through all that sensor information to figure out how stormwater could be most efficiently routed through the system to prevent flooding.
So I'm actually analyzing the data that these sensors provide us. So looking at the data, seeing how the network itself is operating, and then using that data in a control algorithm to tell us how those assets should be controlled, how a gate should open, how a pump should be set.
They are testing out their smart system here in Ann Arbor, as well as other locations around the country. The sensors can test for water quality too. Ponds and wetlands are home to microbes that can break down pollutants.
So a lot of stormwater systems aren't just designed for flooding, they're also designed for water quality. Because what you want to do is you want to treat that water and hold it back during these storm events to effectively remove the pollutants that are in that water.
Kirkez likens this effort to building a self-driving car. The ultimate goal is autonomy.
What if you not necessarily took the human out of the loop, but you helped the human make better decisions, and ultimately once trust builds over time into this autonomous system, then you might have something like a self-driving car one day, but for water systems.
For Evan Pratt, this partnership has been win-win.
For me to replace this infrastructure would cost millions of dollars. But for just $25,000, we found a way to squeeze 33% better performance on pollutant loading out of it.
Building smart stormwater systems, putting autonomous technology to work when the water starts to rise. For Science Nation, I'm Miles O'Brien.